continuing with the test. In a storage tank, 3,000 litres of valuable liquid, presumably water, that's valuable. Someone left the tap on. The liquid escaped 30 litres per minute. Now, at t equals 0, you'd have 3,000. After 1 minute, you would have 2,000. What am I doing? Sorry. Wrong. I'm only losing 30, not 300. 2,970. Then 2,940. 2,910. 2,880. You want to check. Here it's easy because it's just going 1, 2, 3, 4, 5 minutes. But always check that. Like, do they start at 0? Then it'd be 3,000. Do they maybe skip to 10 all of a sudden? Or make jumps in these numbers? Right? So just make sure you read those tables carefully when you have to fill them out. Dependent, independent variable. This table's set up correctly. Like you do in year 8, you have your x on top in a table like that. The x is the independent variable, y is dependent, but even if those were mixed up, it does make logical sense. The volume that you're losing depends on, we could say that, or the volume that's left depends on how long the tap's been open for. So the volume depends on time, right? Time is independent. When you're in science, they'll say the independent variable is the thing that you change, right? Time is independent variable. Independent. The volume is the thing that you would be measuring, the amount of liquid left is dependent. Although I guess you could measure time as well, but sometimes that what's been changed versus what's been measured can help you figure out what's independent, what's dependent. Now do a graph. Okay. Now I think I can remember those numbers. I'm going to have to scroll down. Right. So let's draw a graph. I want to have my grid showing. All right. It's only 5 minutes. So when you do your graph, it's going to be hard to draw with this pen. You want to space it out and make it fairly big, right? And you want to label. Now, like I said before, independent variable, it goes on the x-axis. Dependent goes on the y. But it's very important that you label. There's a mark just for writing that with units. Right, what are we measuring the volume in? The person reading your graph needs to know. The time, is it seconds? Is it hours? Days? Nope, it's minutes, so put that on. Space things out a bit. It's only 5 minutes, right? You want to space things out evenly. I reckon you could probably do about 4 squares for every minute. 1, 2, 3, 4. Do this carefully, evenly, like on the side of a ruler. You know? Okay. Now, we have to go all the way up to 3,000. We'll skip a bit of scale. If you are skipping some scale, you need to indicate that. You can do it that way, or you could do this. You need to show that you're going to skip from 0 up to something else, right? I actually prefer the little zigzag. I probably should have drawn it in from the start. So what I mean is I do a little something like that. And then I continue with my line, right? I've got to think. The lowest value was 2,850, and I've got to go up to 3,000. So now I'm thinking, well, maybe if I start here, what if I went 800, 850, 900, 950, 3,000? Maybe I'll go up in 40s, just to try and make the graph a bit bigger, space things out a bit more. 2,800, 2,840 litres, 2,880 litres, 2,920 litres. You get the idea. 3,000. All right, when t equals 0, I was on 3,000, then I dropped 30. So by the time I'm here on 1, I'm down to 2,970. 1, 2, 3, 4. Okay, then I drop another 30. So I'm here. 1, 2, 3, 4. Drop another 30. I'm there, I should be. 2,910. Then another 30 is 2,880. There. Checking my dots line up with my times. And one more drop of 30. Right. You can join that all up. Do it in the same color. You can see that I forgot to bring my ruler today. Your graph will hopefully look a bit better. It's quite difficult using this computer pen. So, but if I saw that in a test, I'd probably be a little bit unhappy about that line not being on the dots. It should be a straight line, but I'd probably still give it 4 marks, right? Because it's labelled, the scale's even, right? And that's what you need to do. Something like that should hopefully be an easy way to get marks on a test, because graphs always have quite a few marks associated with them. What is the slope of the graph? Well, we know that every minute we lose 30 litres, right? So we drop minus 30 every 1 minute. If I was just writing a gradient number or a slope, I would write minus 30, okay? So I think that's pretty straightforward. You can see it in the table. You had a difference. Every minute you were going minus 30, minus 30, minus 30. Interpreting the slope, right? So the slope equaled 30. We need to write what that means, and interpreting the vertical intercept. Normally it would be a y-intercept. I guess here y is v for volume. So they've called it the vertical intercept. And for us, that was 3,000, right? So what does this mean? It means every minute, something like this, 30 litres is lost from tank. Or you could say volume decreases by 30 litres from tank. The vertical intercept, so you could say at time equals 0, there was 3,000 litres, write it properly, there was, or is, was, I think was 3,000 litres in tank, right, before someone opens the tap. Find an equation connecting V. So normally it would be y equals mx plus c, as you know, but here y is volume and x is time. We know the gradient, we know the y-intercept, so V equals minus 30t plus the 3,000 that we started with. Okay, I'll have to remember that equation when we go down to the next questions. Right, moving down. on the page, find the volume of the liquid left in the tank after 18 minutes. Volume was minus 30. Now T is 18, so I'm timesing by 18, plus 3,000. 3 18s are 54, but you've got 30 18s, 540, plus 3,000. You're left with 2,460 litres. How long will it take for the tank to only have 10% of its original? So 10% is left. 10% of, brackets means of in maths. 10% left would be 300 litres left. So the volume is 300 minus 30t plus 3,000. Let's subtract 3,000 from both sides. So let's divide both sides by minus 30. We've got t equals, we can divide both by 10. We've got 27 on 3 would be 9, but we've got 270 on 3. We've got 90 minutes, or if you liked, optional answer, 1.5. Use a 4. You don't have to write this. It doesn't say that you have to write in hours. So either answer there is correct. Right, let's try and, I'm doing these solutions in parts, but I think we can whip through the circles questions, hopefully. Write equations of circles. All right, so we've always got this form, x minus h squared. We've explained in class that's coming from distance formula, really. And so we're just applying this equation here. The center, you just need to be careful. If that's a positive 4, that's a minus 4, right? If that's a minus 7, this will be a plus 7. Now the radius has to be squared. 17 squared, 289. Done. Okay, the radius is square root 7. Let me read the whole thing. Write the equation of a circle which has a radius of square root 7 units, and the circle is concentric with this other circle here. Concentric, they do tell you, same center. So, like, for example, like a target, like a bullseye, playing darts, Oh, my pen just stuffed up there. Right, so small circle, big circle, same center, concentric. Right. Okay. Well, the center's easy. We can just rewrite that. In fact, no excuses for getting this one wrong, really, because this is already in the center form, HK. So that can stay the same. This one had a radius of 5, but now the radius is square root 7. Just remember you've got to square that, right? Like I've written there. Okay, a couple more equations of circles on the next page. Let's have a look. Okay. Right. I'll leave the formula there because I might refer to it, I'm not sure. The centers, well, we've talked about this. Just remember, if that's minus 2, you'll have x plus 2. If that's a plus 4, you've got to change your sign, so it'll be a minus 4. It will equal some radius, but they haven't told me what that is. But what I do know is that I've got a point on the circle that has to fit with this equation, right? So I can simply just substitute 3, 1, right, into this equation. So it follows that we would get 3 plus 2 is all squared, right? Don't mix up your x's and y's. X is 3, y is 1. 1 minus 4 squared. We'll find out what it equals, then we'll know what the radius was, and we'll know what the equation was, right? So that's going to be 5 squared, that's 25. Here we've got 1, that's a minus 3 squared. Minus 3 times minus 3 is 9. This equals 34, right? Hence, just to properly finish this question, the equation I'm looking for is x plus 2 all squared, y minus 4 all squared, and it equals 34. The radius would be the square root of 34. Okay, that's that one done. I think we can do question 5. Let's have a look. I've got 3. All right, I'll do question 5 and then we might draw a line in the sand. Let's do these two. So what's the center? You can just read it from this formula. This is already in the center radius form, so we can say center equals 6 minus 5, again swapping that sign around, and radius, just don't forget to square root, because this is radius squared. Here I'd be completing the square, so I've got x minus 2 all squared. Now that's coming from that and that, right? This is something that we've talked a fair bit in class about, how to complete the square. So we just very quickly, we would know, hopefully, that if that here is a square, right? Sorry, plus 4. It can be written like this. You know, this is your old a squared minus 2ab plus b squared equaling a minus b all squared. And it, you know, that bit's right, that bit's right. It's fitting this idea of a square, except we didn't have the 4, right? So you need to subtract away the 4, right? I'll just tidy this up. All right, with the y's. So basically what I'm doing is halving. I'm looking for this number and just halving it. Y minus 3 squared, but I've now introduced a 9. 3 squared, when I expand that out, I don't want the 9. I've also got a 3. All equals 0. So once I've got it into this center radius form, we're going to have 16. Once I've got it into this form, I should be able to very quickly see that the center is 2, 3, and the radius is 4. Okay, so that's how I do it. I know the book has a shortcut method. If you are really a bit shaky on completing the square, there is a formula in your booklet so that you can take that value and halve it to get your x coordinate. Don't forget it's a minus though, and take that value and halve it. You can get your center that way. It's a bit of a clue here. Find the center and radius of circles if possible. This is looking a bit dodgy, like it might not be possible because that's a 10, that's a 16. I mean, maybe you might attempt to start completing the square on something like this. Well, where would you go with it? I mean, if I was to take 1/10 there, that would be 4/10. But then this introduces a 4 on 100 I don't want. wise? Well, basically not possible. I think I've got a bit of an advantage for knowing that's not possible because I know that if you have different coefficients here, what is it, ax squared plus bx, by squared equaling ab, I think, or the other one is, I'll have to check that. So we don't teach ellipses anymore. I know this one. X squared on a squared, y squared on b squared equaling 1. What's going to happen here is it's going to fit that pattern. I'd have to do a bit of work to rearrange it to equal 1, but it would be possible. I could have some x squared divided by 10 to begin with. And you'd have anyway, how are you going to know if you see a question like this? I suppose if you've got different coefficients, that if you cannot make a 1, let me explain what I'm trying to say. If you cannot get 1 and 1 there, it's probably an ellipse. I can remember it. I could type it into Desmos and have a look. So I probably have that. Was it 10x squared, 16y squared? So these used to be in the old, used to do, I think it was in the old specialist maths, they used to do conics. That was a +3 or a -3? -3. There you go. Maybe if I zoom in, you'll see that's not circular. Right, so forget about worrying where its center is. These things actually have 2 focal points. Because you've got a long axis. Oh, it won't let me draw anymore. You've got a long axis and a major and minor axes. Long and short. So that one, I think they kind of gave you a clue here. If possible, there was one that wasn't. Yeah, a bit of an odd question. Alright, well I might stop the video there with that last question. It was a bit awkward. Left of center, left of circle. And then we'll pick it up with question 6 in the next video.